And now we're working on the G3 reflection, and this is basically, we're going to be calculating probabilities from z-scores. Hopefully you learn how to do that. Now these notes were kind of a very calculator-oriented, my apologies, but this was back in the day. Haven't had a chance to update these. Which of the following is a true statement? The area under the standard normal curve between 0 and 2 is half the area between -2 and 2. That one sounds right. So let's just go back. I'm going to actually go back to my previous notes. So your z-score here, this is a z-score of -2 and 2. And if you go 0 to 2, that is cutting it symmetrically in half. So I would agree with that. The area under the standard normal curve, that should probably say is twice the area between 0 and 1. So 0 to 2 is twice 0 to 1. Well, if we look here, 0 to 2 is the yellow and the green. That is not twice the yellow area, so that is false. Whoops, wrong one. And for a standard normal curve, the interquartile range is approximately 3. Oh, why do they all say the same thing? Interesting. Well, it's not those. You get a freebie. So the correct answer is A. That's funny. I don't know how that happened. I guess I probably meant 2 and 1. I might go edit those back so they say 2 and 1. Okay, now let's go to the fun part. A piece of clothing takes an average of 38 minutes to move through the assembly line. The standard deviation is 4 minutes, and the distribution is approximately normal. What is the probability that a piece of clothing will take over 45 minutes? So you're basically going to go to the normal distribution staplet, and you're going to need to set up your mean and your standard deviation. So the mean's 38, standard deviation is 4. So I'll put 38 and 4. And that's our distribution. All right, so let's see. What is the first question? I'm going to kind of copy this in just so. So if we did this, go to the next page. Oh, this is for later. Don't worry about that. You paste it in here. So this is our problem, right? So I will go ahead. What is the probability it will take over 45 minutes? Right? I said 45. Yeah, 45. So you want an area to the right of the value, and you just put the 45 minutes in, hit calculate area. It's nice to show the labels, so it labels the area for you. It shows the normal model. With my AP kiddos, I'm very particular about this. And that kind of shows you all the answers that you need right there. So it's 0.0401. Go ahead and paste that in here. So that's part A. All right. So 0.0401. So we can pretty much figure out everything we need. So that's this answer right here. What is the probability a piece of clothing will take less than 35 minutes? So let me put the problem down here. Come on, text box. There we go. And if I go less than 35, so that means to the left of value, 35, calculate. So there's your area. So I'm just going to go, I'm not going to get the whole picture. I just want to make sure you know what your settings are. All right. And so put that in. Boom. And so the area is 0.2226. So that's this piece right here. I'm going to actually slide that right there. Okay. And we'll go ahead and click 0.2266 or something close to it. That looks close to it. What is the probability a piece of clothing will take between 35 and 40 minutes? So I'll paste the question in here. And let's find out. All right, so we'll put 35 to 40. So we want between two values, 35 and 40. And calculate area. You can see it shows the 35, it shows the 40. Also shows the z-scores for you. So it will you could use Staplet to calculate your z-scores if you really wanted to. You just got to put the normal, the mean, and the standard deviation in there. So there we go. Oh, go ahead and paste that in. And that is the area for problem So it's a 0.4648 area. All right, 0.4648. There we go. Okay, so let me go ahead and pick that. 4648, that's about that. Submit our answer. These should all be correct. So you should find that with the Staplet, it's actually even easier than using the empirical rule. And you're like, why do we use the empirical rule? Well, sometimes you don't have access to a Staplet. And in the old days, we had tables. We had to look these things up in. Okay, the table on the warm-up shows the grades for Mrs. Overman's 60 AP Stat students on a unit test. So this is the table we're looking at. What is the probability a student fails the test? What is the probability a student passes the test? All right, so first of all, let's go ahead and do probability a student fails the test, right? So 1, what is the probability a student fails the test? Well, they fail if, how do they fail? They fail if they were, so 8 students failed out of 60, right? So 8 divided by 60, and we'll just Google it. 8 divided by 60, 0.133, etc. Pretend 0.1333. All right, so we'll go ahead and find the answer that matches that. That's pretty close to that. So what's the probability they pass? Well, let me go get the question again. Well, if they pass the test, that's just the opposite of failing. Oops, I'll keep that red. And so I can just say opposite of failing. So I don't even have to calculate every one minus 0.1333, blah, 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 which is approximately 0.867, if I recall correctly. I'm going off the top of my head on that one. And there it is. And then here's the fun part. What is the expected test grade? So for that, we're going to need to do some work. So we're going to go ahead and we're going to figure out 3 divided by 60. We know there are 3. Okay, 3 divided by 60, 0.05. So I'm going to go ahead and put a 0.05 in here. All right. And then 5 divided by 60 is 1/12, but I should have that memorized. I should know my 12s. 0.0833. We'll do that many decimals. 16 divided by 60 is 0.267, you think? 266. Now, again, depending on how you round these, there'll be slightly different answers, okay? So don't freak out too much if that's the case. I'm going to actually just type another line here. 17 divided by 60. Yes. Need a calculator for this one for sure. 0.2833. Go ahead and put this one right there. And then 13 divided by 60. 0.2167. And then last but not least, 6 divided by 60. I know that one's 0.1%, 10%. Sorry. Okay, so now what we're going to do, I might have to move this for a second so I can look at those numbers, and we're actually going to go to a Staplet. Oh, I need to do one more thing, so let me bring this back. So I'm going to have to put a value in here. So what the value is going to be is the average of these two. So it's going to be, let's see if I move this picture slightly to the right. And then I'll move this slightly to the right. And that slightly to the right. There we go. So I'm going to show you the averages. I'm going to put in 50 plus 59 divided by 2 is 54.5. And then you'd have 64.5 and 74.5, etc. All right. So that's the value we're going to use in the Staplet. So that's kind of annoying, I know. So I'm going to go ahead and go to a Staplet. And we're going to do discrete random variables. So this is test scores. And I put the first value, which was 54.5, and that had 0.05. 64.5, and that had 0.0833, and I got to keep adding rows. 74.5, we had 0.2667. 84.5, we had 0.2833. 94.5, we had 0.2167. And this probably feels weird. You won't have to do a lot of these. This is 104.5, and it's 0.1000. Okay. So that gives me the distribution, and there is your mean and your standard deviation. This is what we need to answer the last two questions on this problem. So I will go ahead and bring my Cami back. Now I can paste the solution here. There it is. So it's basically use random variable stapplet. And use averages for the quantitative, for the test scores to calculate the mean and standard deviation. And you can say the mean here is 82.834. There should be an answer. There we go, 82.8. And our standard deviation is 12.8. So we put that in there and we hit submit. And then you can complain down here in your feedback. Mrs. Overman, what were you doing? I mean, this part wasn't too bad, 1 and 2. I wonder if someone, I guess I was just trying to make sure. This is older material, but that's not bad for you to learn your older material. I'll admit, though, we don't do a lot of these. Even my AP kiddos don't do a lot of these. So, but thank you for bearing with me. It didn't take us that long to go through this assignment. So share what you learned or had issues with right here.